Hey guys, tonight we begin with one of the most mind-bending truths about our universe. A truth so counterintuitive that it challenges everything your brain thinks it knows about space, expansion, and where exactly you're standing in the cosmic order. We're diving deep into why the universe has no center, yet somehow expands everywhere at once. It's a concept that will twist your understanding of reality itself. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And let me know in the comments where you're tuning in from and what time it is for you. It's always fascinating to see who's joining us from around the world. Now, dim the lights. Maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. Picture this. You're standing in your backyard at midnight, staring up at the stars. Thousands of tiny lights scattered across the darkness like glitter thrown against black velvet. Your brain, doing what brains do, immediately starts looking for patterns, for meaning, for some kind of center to this cosmic display. Maybe you point to the brightest star and think, that's the middle. Maybe you imagine Earth sitting at the heart of it all, with everything else spinning around us like some grand celestial carousel. But here's the thing that's going to keep you awake tonight. You're wrong. We're all wrong. And not just a little bit wrong, catastrophically, beautifully, mind-meltingly wrong. Because the universe, this vast expanse of space and time and matter that contains literally everything we know, has no center. None. Nowhere. Not here. Not there. Not anywhere. And yet, somehow, impossibly, it's expanding everywhere at once. Right now, as you sit there trying to wrap your head around this, galaxies millions of light years away are racing away from us. But here's the kicker, they're not racing away from us because we're special, they're racing away from everything. Every point in space is expanding away from every other point. It's like the universe is playing the world's most complex game of cosmic dodgeball, except instead of trying to hit each other, everything is trying to get as far away from everything else as possible. And this isn't some abstract theoretical nonsense dreamed up by physicists with too much time on their hands. This is measurable, observable, undeniable reality. We can see it happening. We can measure it. We can predict it. But understanding it, really understanding it, that's where things get interesting. Let me tell you why this matters. Because once you grasp this concept, really grasp it, everything changes. Your perspective on where you are in the universe shifts. Your understanding of space and time evolves. You start to realize that the very fabric of reality is stranger, more beautiful, and more mysterious than anything science fiction has ever imagined. Tonight, we're going to unpack this cosmic puzzle piece by piece. We'll explore how scientists first discovered this mind-bending truth. We'll dive into what it actually means for space itself to expand. We'll examine why your intuition keeps telling you there must be a center somewhere and why your intuition is spectacularly wrong. And by the end, you'll understand one of the most profound discoveries in all of human history. But first, let's talk about why this is so hard for our brains to accept. Because the problem isn't that the universe is complicated. The problem is that our brains evolved to understand things that are human-sized, moving at human speeds, in human environments. We're really good at understanding that when you throw a ball, it follows a curved path and lands somewhere. We're excellent at figuring out that when something explodes, the pieces fly outward from a central point. We're masters at recognizing that when a crowd disperses, they spread out from wherever they were gathered. But the universe doesn't care about our intuitions. the universe operates on scales so vast and principles so fundamental that our everyday experience is essentially useless. It's like trying to understand the ocean by studying a single drop of water. The drop follows certain rules, sure, but it tells you nothing about currents, tides, or the fact that water covers most of the planet. So when we look up at the night sky and see all those stars and galaxies, our brains immediately start applying our everyday rules. We see things spread out in space, so we assume they must have spread out from somewhere. We see motion, so we assume there must be a starting point. We see expansion, so we assume there must be a center. It's not stupidity, it's just biology. Our brains are doing exactly what they evolved to do. But here's where it gets fascinating. The universe is expanding, but it's not expanding into anything. Let me say that again because it's important. The universe is not expanding into some larger space. Space itself is expanding. It's not like a balloon inflating inside a room. It's like the room itself is getting bigger and there's no outside to the room. Think about it this way. Imagine you're an ant living on the surface of a balloon. From your perspective, the balloon surface is your entire universe. Now someone starts inflating the balloon. From your ant's eye view, every point on the balloon surface is moving away from every other point. If you measure the distance between any two dots on the balloon, that distance is increasing. But here's the crucial part. There's no center to this expansion on the balloon surface. Every point looks like the center from its own perspective. The ant at one dot sees all the other dots moving away from it and thinks, clearly I'm at the center of this expansion. But the ant at any other dot sees exactly the same thing. Every ant thinks it's at the center, and they're all equally right and equally wrong. There is no center on the surface of the balloon, just as there is no center to the universe. But wait, you might say, surely the center of the balloon is the center of the expansion, and you'd be right if you could access that center. But remember, in this analogy, the ants are two-dimensional creatures living on a two-dimensional surface. They can't access the center of the balloon any more than we can access some hypothetical center of our three-dimensional universe in a higher dimension. The center, if it exists at all, is literally outside their reality. This is exactly what's happening with our universe, except instead of ants on a balloon, we're three-dimensional beings in a three-dimensional space that might be expanding in ways we can't directly perceive or access. The center, if it has any meaning at all, exists in a realm we can't reach, can't measure, and can't even properly imagine. Now, let's talk about what we actually observe when we look out into space, because the evidence for this centerless expansion is everywhere once you know how to look for it. Every galaxy we can see, with very few exceptions, is moving away from us. Not just moving, racing away at incredible speeds. The farther away a galaxy is, the faster it's receding. This relationship is so consistent, so predictable, that we've turned it into a fundamental law of cosmology. But here's what's really mind-bending. If we could somehow teleport to any of those distant galaxies and look back at our own Milky Way, we'd see the exact same thing. From their perspective, we'd be racing away from them, and every other galaxy would be racing away from them too. Every observer, everywhere in the universe, sees the same pattern, everything moving away from everything else, with more distant objects moving away faster. This is the smoking gun evidence that the universe has no center. If there were a center, observers in different locations would see different patterns. Observers near the center would see things moving away more slowly. Observers far from the center would see things moving away in one direction and toward them in another, but that's not what we observe. The pattern is the same everywhere, which means there's no special location, no cosmic center, no privileged position in the universe. And this brings us to one of the most beautiful and humbling realizations in all of science. We are not special. Earth is not at the center of the solar system. The solar system is not at the center of the galaxy. The galaxy is not at the center of the universe. We exist on an ordinary planet, orbiting an ordinary star, in an ordinary galaxy, in an ordinary part of an infinite cosmos that has no center and no edge. This idea has a name. It's called the cosmological principle, and it states that the universe looks basically the same from every vantage point. No matter where you are, no matter which direction you look, you'll see roughly the same density of galaxies, the same large-scale structure, the same patterns of expansion. You are not at the center of the universe, but then again, neither is anyone else. Every point in space has an equal claim to being the center, which means no point is actually the center. But how do we know this? How can we be so confident that the universe has no center when we can only observe it from one location? The answer lies in decades of careful observations, measurements, and mathematical analysis. We've mapped the positions and velocities of millions of galaxies. We've measured the cosmic microwave background radiation that fills all of space. We've studied the large-scale structure of the universe, the vast web of filaments and voids that spans billions of light years. Every measurement, every observation, every piece of data points to the same conclusion. The universe is homogeneous on large scales. It's isotropic, meaning it looks the same in every direction, and it's expanding uniformly, with every region of space stretching at the same rate. These aren't just theoretical predictions, they're observed facts, confirmed by multiple independent lines of evidence. Consider the cosmic microwave background, the afterglow of the Big Bang that permeates all of space. This radiation is incredibly uniform, varying by only tiny fractions of a percent across the entire sky. If the universe had a center, if we were in a special location, we'd expect to see systematic patterns in this radiation. We'd see it brighter in some directions, dimmer in others. We'd see evidence of our motion relative to some cosmic center. But we don't. The cosmic microwave background is remarkably smooth and uniform, exactly what we'd expect if the universe has no center. Or consider the distribution of galaxies themselves. When we map out where galaxies are located in space, we see an intricate web-like structure. Galaxies cluster together along filaments, separated by vast empty voids. But when we zoom out far enough, when we look at the universe on its largest scales, this structure becomes smooth and uniform. There's no grand pattern pointing toward a center. There's no systematic increase or decrease in galaxy density in any particular direction. The universe looks the same whether we're looking toward the constellation Orion or toward the Southern Cross. This uniformity extends to the expansion itself. When Edwin Hubble first measured the recession velocities of distant galaxies in the 1920s, he discovered that their speed was proportional to their distance. This relationship, now known as Hubble's law, tells us that space itself is expanding uniformly. It's not that galaxies are flying through space away from some central explosion, it's that the space between galaxies is stretching, carrying them apart like raisins in rising bread dough. And here's where the bread dough analogy becomes really useful. Imagine you're a tiny observer living on one of the raisins in a loaf of bread that's rising in the oven. As the dough expands, you see every other raisin moving away from you. The raisins that were farther away to begin with move away faster because there's more dough between you and them to expand. But from your perspective on your raisin, you might think you're at the center of this expansion. Every other raisin is moving away from you in a pattern that makes perfect sense if you're at the center. But of course, an observer on any other raisin would see exactly the same thing. They'd see every raisin, including yours, moving away from them in a pattern that suggests they're at the center. The expansion of the dough is uniform, so every point within it has an equal claim to being the center. In reality, there is no center within the dough itself. The center, if it exists, is a concept that only makes sense from outside the dough in a higher dimension that the raisin observers can't access. This is precisely what's happening with our universe. We see every galaxy moving away from us in a pattern that might suggest we're at the center, but observers in any other galaxy would see the same pattern from their perspective. The expansion is uniform, so every point in space looks like the center from its own reference frame. The actual center, if it has any meaning at all, exists in a realm beyond our three-dimensional space in dimensions we can't perceive or access. But wait, you might be thinking, if everything is moving away from everything else, doesn't that mean the universe started from a single point? Doesn't that mean there was a center at the beginning, even if there isn't one now? This is a natural question, and it touches on one of the most common misconceptions about the Big Bang. People often imagine the Big Bang as an explosion that happened at a specific point in space, with matter and energy flying outward from that central location. But that's not what happened. The Big Bang wasn't an explosion in space. It was an explosion of space. It wasn't matter flying apart in an existing universe. It was the universe itself coming into existence and immediately beginning to expand. Every point in space, every location in the universe, was part of that initial moment. There was no outside, no center, no edge. The Big Bang happened everywhere at once because everywhere was the same place. Imagine trying to find the center of the surface of the Earth. You might pick the North Pole, or the equator, or your hometown, but of course, there is no center to a spherical surface. Every point on the sphere is equivalent to every other point. Similarly, if the universe is infinite in extent, there's no center to be found. And if the universe is finite but unbounded, like the surface of a higher dimensional sphere, then every point is equivalent and there's still no center within the space itself. This brings us to one of the most profound implications of a centerless universe. If there's no center, then there's no edge either. The universe doesn't have borders. It doesn't have walls. It doesn't have a boundary beyond which there's something else. It either goes on forever in all directions, or it curves back on itself in ways that make the very concept of an edge meaningless. Think about it. If you could somehow travel in a straight line through the universe for an infinite amount of time, you'd either keep going forever through an endless expanse of space, or you'd eventually end up back where you started, having traced a great circle through curved space-time. Either way, you'd never hit a wall. You'd never find a sign that says, "End of universe, turn around." The universe is either infinite or it's closed, and in either case the idea of a center becomes meaningless. This is where our everyday experience completely fails us. We live in a world of edges and centers. Your house has a center and edges. Your town has a center and city limits. Even your country has borders and a geographical center. Everything we interact with on a daily basis reinforces the idea that objects have middles and boundaries. So when we try to apply this thinking to the universe, we hit a conceptual wall. But the universe doesn't care about our limitations. It operates according to principles that seem impossible from our human perspective. And this is exactly what makes it so fascinating and so maddening at the same time. We're trying to understand something infinite using brains that evolved to understand finite things. We're trying to grasp something with no center using minds that are constantly looking for patterns and focal points. Let me throw another curveball at you. Not only does the universe have no center, but every point in it is expanding away from every other point at exactly the rate you'd expect if that point were the center. This isn't a coincidence. It's a fundamental property of how space itself behaves when it expands uniformly. The mathematics is actually quite elegant, even if the concept makes your brain hurt. Here's the key insight that took scientists decades to fully appreciate. When we say the universe is expanding, we're not talking about stuff moving through space. We're talking about space itself getting bigger. The distance between any 2 points that aren't gravitationally bound together is increasing, not because those points are moving, but because the space between them is stretching. It's like having a ruler made of elastic. If you stretch the ruler, the distance between any 2 marks on it increases, but the marks themselves haven't moved relative to the ruler. They've only moved relative to each other because the ruler itself has been stretched. In the universe, space is the elastic ruler and galaxies are the marks. The galaxies aren't flying through space away from some central point. They're being carried apart by the expansion of space itself. This creates a weird situation where every galaxy can legitimately claim to be at rest. From the perspective of any galaxy, it's just sitting there minding its own business while all the other galaxies rush away from it. Each galaxy sees itself as stationary and views the recession of other galaxies as evidence that it must be at the center of the expansion. But of course, they can't all be at the center, which means none of them actually are. Now let's talk about what this expansion actually looks like in practice, because the details are even stranger than the concept. The expansion of space is described by something called the Hubble constant, which tells us how fast space is stretching. But here's the thing, the Hubble constant isn't actually constant over time. It's changing as the universe evolves, which means the rate of expansion is accelerating. That's right. Not only is the universe expanding, but it's expanding faster and faster. This discovery, made in the late 1990s, completely blindsided the scientific community. Everyone expected that gravity would gradually slow down the expansion, eventually bringing it to a halt or even reversing it. Instead, we found that some mysterious force is pushing the universe apart at an ever-increasing rate. We call this mysterious force dark energy, and it makes up about 68% of everything in the universe. We don't know what it is. We don't know where it comes from. We don't even know if it's a force in the traditional sense or just a property of space itself. But we can measure its effects, and those effects are dramatic. Dark energy is literally tearing the universe apart, and it's getting stronger over time. This accelerating expansion has profound implications for the future of the universe. If dark energy continues to dominate, the expansion will never stop. In fact, it will keep getting faster and faster until galaxies are receding from each other so quickly that light from one can never reach another. Eventually, even atoms might be torn apart by the expansion of space. But let's zoom out from this cosmic horror story and focus on what this tells us about the nature of space and time. The fact that space can expand, that distances can increase without objects actually moving, reveals something fundamental about the structure of reality. Space isn't just an empty container where things happen. It's a dynamic, evolving entity with its own properties and behaviors. Einstein showed us this over a century ago with his theory of general relativity. Space and time aren't separate, absolute entities. They're woven together into a four-dimensional fabric called space-time, and this fabric can be stretched, compressed, twisted, and curved by the presence of matter and energy. The expansion of the universe is just space-time doing what space-time does, responding to the matter and energy it contains. But here's where it gets really mind-bending. If space itself is expanding, what's it expanding into? This question haunts almost everyone who first encounters the concept of cosmic expansion, and the answer is both simple and profoundly unsatisfying. Space isn't expanding into anything. There's no larger container, no higher dimensional space that our universe is growing within. The expansion is intrinsic to space itself. Think of it this way. When you ask what space is expanding into, you're assuming that expansion requires an external reference frame, some larger space within which the expansion occurs. But that assumption is based on our everyday experience with objects expanding within our familiar three-dimensional space. A balloon expands into the air around it. A city expands into the countryside around it. But space itself has no outside, no surrounding medium into which it can expand. This is where the limitations of analogy become apparent. Every comparison we make between cosmic expansion and familiar objects breaks down at some point because familiar objects exist within space, while space itself is the thing that's expanding. It's like trying to understand color by studying only black and white photographs. The tools we have are fundamentally inadequate for the task. And this brings us to another crucial point about the centerless universe. Not only is there no spatial center, there's no temporal center either. The Big Bang didn't happen at a specific time and place. It happened everywhere, at every point that now exists in our universe, all at the same moment. Every location in space can trace its history back to that initial moment of cosmic expansion. This means that the cosmic microwave background radiation we detect isn't coming from a particular direction in space. It's coming from every direction because it was emitted from every point in space when the universe became transparent to light, about 380,000 years after the Big Bang. We're not seeing the radiation from some distant source. We're seeing the radiation from our own location in space, as it existed billions of years ago. It's like being inside a sphere where every point on the inner surface is simultaneously the source of light. No matter which direction you look, you see the same glow, because the glow is coming from everywhere. The cosmic microwave background isn't a window into some distant region of space. It's a window into the ancient past of our own piece of the universe. This temporal aspect of the centerless universe creates another layer of strangeness. When we look out into space, we're also looking back in time. The farther away something is, the longer its light has taken to reach us, so we see it as it was in the past. The most distant galaxies we can observe appear as they were when the universe was less than 1 billion years old, still young and actively forming its first generation of stars. This means our view of the universe is like a temporal onion, with layers representing different cosmic epochs. The nearby galaxies show us what the universe looks like today. The more distant ones show us what it looked like millions, then billions of years ago. And the cosmic microwave background shows us the universe as it was in its infancy, still glowing from the heat of its own creation. But here's the crucial point. Every observer, everywhere in the universe, sees this same temporal onion structure. An observer in a galaxy 10 billion light-years away would see our Milky Way as it appeared 10 billion years ago, when it was still forming and very different from how it appears today. They would see their own local region as it appears in their present moment, just as we see our local region in our present moment. This creates a strange situation where every observer sees themselves at the center of a temporal sphere, looking out into the past in all directions. But this isn't because they're actually at the center of anything. It's because light has a finite speed, and the farther you look, the farther back in time you see. Every observer experiences this same effect, which means every observer sees what appears to be evidence that they're at the center of the universe. The universe is playing a cosmic trick on us. It's designed in such a way that every observer everywhere sees patterns that suggest they might be in a special central location, but these patterns are just artifacts of the finite speed of light and the uniform expansion of space. They don't indicate that any location is actually special or central. They're just the inevitable result of observing an expanding universe from within. This is why the discovery that the universe has no center was so difficult to make and so hard to accept. The evidence that seems to suggest we're at the center is real and measurable. We really do see all distant galaxies receding from us. We really do see the cosmic microwave background coming from all directions around us. We really do appear to be at the center of our observable universe. But the key word there is observable. The observable universe is the sphere of space around us from which light has had time to reach us since the Big Bang. It's centered on us by definition because it's defined by our ability to observe it. But the observable universe isn't the same thing as the entire universe. It's just the part we can see from our particular location at this particular moment in cosmic history. An observer in a different galaxy would have their own observable universe, centered on their location and extending the same distance in all directions. Their observable universe would overlap with ours in some regions, but extend into regions we can't see. Neither observer would be at the center of the actual universe, but both would be at the center of their own observable universe. This distinction between the observable universe and the entire universe is crucial for understanding why the universe can have no center. The observable universe, by definition, has a center. It's wherever the observer is located. But the entire universe, the totality of space and everything in it, has no center because there's no special location within it. It's like the difference between your field of view and the entire landscape around you. Your field of view is centered on your location because it's defined by what you can see from where you're standing. But the landscape itself doesn't have a center. It extends in all directions, and every observer within it has their own field of view centered on their own location. Now, let's dive deeper into what this means for our understanding of space and time. If the universe truly has no center, then the very concepts of absolute position and absolute motion become meaningless. There's no cosmic reference frame, no universal coordinate system that tells you where you are in any absolute sense. This has profound implications that go way beyond just astronomy. It means that when you say you're moving, that statement is incomplete. Moving relative to what? Your car is moving relative to the road, but the road is moving relative to the Earth's surface, which is moving relative to the Earth's center, which is moving relative to the Sun, which is moving relative to the center of our galaxy, which is moving relative to other galaxies. But there's no final reference frame, no ultimate standard of rest against which all motion can be measured. Einstein built his entire theory of relativity on this principle. He realized that the laws of physics must be the same for all observers, regardless of their motion, because there's no absolute standard of motion to compare against. What looks like rest to you might look like motion to someone else, and both perspectives are equally valid. The universe doesn't care about your personal reference frame. It treats all observers democratically. But this creates a philosophical puzzle that's been bothering humans for centuries. If there's no center to the universe, no absolute reference frame, no special location, then what makes any place significant? What makes Earth important if it's just another random point in an infinite expanse of space? The answer is both humbling and liberating. Earth isn't cosmically significant. Our solar system isn't special. Our galaxy is just one of hundreds of billions. But that doesn't make us insignificant. It makes us rare. In a universe with no inherent meaning, no built-in purpose, no cosmic plan, we get to create our own significance. We get to decide what matters. And here's something beautiful to consider. The fact that the universe has no center means that every location is equally valid, equally real, equally worthy of attention. The view from Earth is just as legitimate as the view from any other planet around any other star in any other galaxy. We're not at the center of the universe, but we're not on the periphery either. We're exactly where we belong, in a cosmos that treats every location with perfect democratic indifference. Let's zoom in on what this expansion actually feels like from our perspective. Right now, as you sit there reading this, space itself is expanding around you. The distance between our galaxy and the nearest major galaxy, Andromeda, is, well, actually it's shrinking because gravity is stronger than expansion on these relatively small scales. But the distance between our local group of galaxies and more distant galaxy clusters is increasing every second. You can't feel this expansion because it's happening on scales much larger than anything in your everyday experience. The expansion of space is negligible over distances smaller than tens of millions of light years. Your body isn't expanding. The Earth isn't expanding. Even our solar system isn't expanding. Gravity holds these structures together much more strongly than cosmic expansion can pull them apart. But venture out far enough beyond the gravitational influence of our local neighborhood, and the expansion becomes dominant. Galaxy clusters separated by hundreds of millions of light years are racing apart at thousands of kilometers per second. It's like the universe is playing a cosmic game of tug-of-war between gravity, which wants to pull everything together, and dark energy, which wants to push everything apart. On small scales, gravity wins. On large scales, dark energy dominates. This creates a hierarchy of structure in the universe. Atoms stick together through electromagnetic forces. Stars and planets are held together by gravity. Solar systems are gravitationally bound. Galaxies are held together by the combined gravity of all their stars and dark matter. Galaxy groups and clusters are held together by their collective gravitational pull. But beyond that, expansion takes over, and the largest structures in the universe are being slowly but inexorably torn apart. Now, let's talk about something that might blow your mind even more than the centerless expansion. The expansion of space actually creates new space. As the universe grows, more space comes into existence between existing objects. This isn't like stretching a piece of fabric until it becomes thinner. It's like the fabric itself is growing, becoming more extensive without becoming less dense. Think about what this means. Every second, the universe contains more space than it did the second before. The total volume of the universe, if it's finite, is increasing. If it's infinite, then infinity is somehow becoming more infinite, which sounds impossible but is actually a well-defined mathematical concept. This creation of space happens everywhere simultaneously. It's not happening at the edge of the universe, because there is no edge. It's not happening at the center, because there is no center. It's happening between every pair of distant objects, in every region of space at every moment. The universe is literally growing from within. And here's something that will really cook your brain. This creation of space doesn't violate conservation of energy, even though you might think creating something from nothing should require energy. The reason is subtle and beautiful. As space expands, the energy density of radiation decreases. Light waves get stretched out, becoming longer and carrying less energy. The cosmic microwave background radiation that fills the universe is constantly losing energy as space expands and its wavelengths stretch. Where does this energy go? It goes into the gravitational field of the expanding space itself. The energy that's lost from radiation is exactly balanced by the negative gravitational energy of the expanding universe. It's like a cosmic accounting system that always balances the books, even as it creates more space and time. But wait, you might ask, if space is expanding everywhere, why don't we see nearby objects moving away from us? Why isn't your coffee cup receding from you at cosmic speeds? The answer brings us back to the fundamental nature of what expansion actually means. Expansion doesn't mean that objects are flying through space away from each other. It means that the space between objects is growing. But if objects are held together by forces stronger than the expansion, those forces can resist the stretching of space. Gravity, electromagnetic forces, and nuclear forces can all overpower cosmic expansion on small scales. Your coffee cup stays on your table because the electromagnetic forces between atoms are vastly stronger than the tiny stretching of space that occurs over such small distances. The Earth stays in orbit around the Sun because gravity is much stronger than expansion over the scale of our solar system. Even our entire galaxy holds together because the gravitational attraction between its stars and dark matter completely overwhelms the gentle stretching of cosmic expansion. It's only when you get to truly vast scales, distances measured in hundreds of millions or billions of light years, that expansion becomes the dominant force. At these scales, there's not enough matter to generate the gravitational pull needed to resist expansion. Space wins the tug of war, and objects get carried apart by the growth of the universe itself. This creates an interesting boundary in the cosmos. Within gravitationally bound systems, the normal rules of motion apply. Objects can move toward each other, orbit each other, collide with each other. But between these systems, on the largest scales, everything is moving apart due to expansion. It's like islands of normal physics floating in an ocean of expanding space. And here's where the story takes another strange turn. The expansion isn't just continuing, it's accelerating. When scientists first measured this acceleration in the late 1990s, they couldn't believe their data. They checked and rechecked, looked for errors, questioned their assumptions, but the evidence was undeniable. The universe isn't just expanding, it's expanding faster and faster. This acceleration is driven by dark energy, the mysterious force that makes up the majority of the universe. Dark energy behaves unlike anything we're familiar with. While matter and radiation become less dense as the universe expands, dark energy maintains constant density. As space grows, more dark energy comes into existence to fill it, creating an ever stronger push that drives galaxies apart at ever-increasing speeds. If this continues, and we have no reason to think it won't, the future of the universe is both spectacular and terrifying. Billions of years from now, the expansion will have carried distant galaxies so far away that their light will no longer be able to reach us. The observable universe will gradually shrink as galaxies disappear beyond our cosmic horizon. Eventually, our own local group of galaxies might be the only objects visible in the night sky. An observer in that far future would see a universe that appears almost empty, with just a handful of nearby galaxies surrounded by endless darkness. They might conclude that the universe is small and static, never guessing that it was once filled with hundreds of billions of galaxies receding into invisible distances. But even that's not the end of the story. If dark energy continues to strengthen, it might eventually overcome not just gravity on cosmic scales, but all the fundamental forces that hold matter together. In a scenario called the Big Rip, the acceleration could become so extreme that it tears apart galaxy clusters, then galaxies, then solar systems, then planets, then atoms themselves. The universe that began with no center and has been expanding everywhere might end by expanding so violently that it destroys its own contents, leaving nothing but isolated subatomic particles racing apart through an ever-growing expanse of empty space. It's a cosmic death that mirrors the cosmic birth, with expansion triumphant at both ends of time. But let's step back from this distant apocalypse and consider what we've learned about our place in this centerless, expanding cosmos. We exist in a universe that has no special locations, no preferred directions, no cosmic landmarks to guide us. Every point in space is equivalent to every other point. Every observer sees the same large-scale patterns. Every location has an equal claim to being important. This might seem depressing at first. If there's no center to the universe, no special place, no cosmic significance to our location, then what makes us matter? But consider the alternative. In a universe with a center, there would be a hierarchy of importance. Some locations would be more significant than others. Some observers would have better views, more privileged positions, greater cosmic relevance. Instead, we live in a universe that treats every location democratically. The laws of physics are the same everywhere. The large-scale structure looks the same from every vantage point. Every observer, whether they're on Earth or in a galaxy billions of light years away, sees themselves at the center of their observable universe and experiences the same cosmic expansion patterns. This democratic universe doesn't diminish our significance, it universalizes it. If every location is equally valid, then our location is as meaningful as any other. If every observer has an equally legitimate perspective, then our perspective matters just as much as anyone else's. We're not the center of the universe, but we're not on the margins either. We're participants in a cosmic democracy where every voice counts equally. And there's something profoundly beautiful about living in a universe that's expanding everywhere at once. It means that the cosmos is constantly creating new space, new possibilities, new room for existence to unfold. The universe isn't running out of room. It's making more room every second, growing and stretching and opening up new territories for matter and energy and perhaps life to explore. This expansion connects us to the deepest rhythms of cosmic evolution. The same process that's carrying distant galaxies away from us is the process that created the space we inhabit. The expansion that seems to be isolating us is actually the expansion that made our existence possible. Without cosmic expansion, the universe would have collapsed long ago under its own gravity. Without the stretching of space, matter would never have had the room to cool, condense, and organize itself into stars and planets and life. We are children of cosmic expansion, products of a universe that chose growth over stagnation, exploration over consolidation, endless becoming over static being. And that expansion continues around us and through us and beyond us, creating new chapters in the cosmic story every moment. So when you look up at the night sky and see those distant points of light, remember what you're really seeing. You're seeing a universe with no center and no edge, expanding everywhere at once, creating new space between every pair of distant objects. You're seeing a cosmos that treats every location with perfect democratic indifference, where every observer is equally valid and every perspective equally meaningful. You're seeing evidence of the most profound discovery in human history, the realization that we live in an infinite or nearly infinite space that has no center, no boundaries, no special locations, a universe that's simultaneously vast beyond comprehension and intimately connected, where every point participates in the same cosmic expansion that started with the Big Bang and continues through this very moment. And perhaps most remarkably, you're seeing this centerless universe from your own unique vantage point, the only perspective you'll ever have, in a cosmos that somehow manages to make every perspective both utterly ordinary and completely special at the same time. Right now, as you're processing this information, something extraordinary is happening in the space around you. The very fabric of reality is stretching, growing, creating new distance between points that were closer together just moments ago. But you can't feel it because the expansion is so gentle, so uniform, so perfectly distributed that it affects everything equally. It's like being inside a photograph that's slowly being enlarged. Every pixel grows at exactly the same rate, so the relationships between objects remain the same even as the overall image gets bigger. You, as a pixel in this cosmic photograph, wouldn't notice the enlargement because you're growing right along with everything else. The expansion isn't something that happens to you, you're part of the expansion itself. This brings us to one of the most elegant aspects of cosmic expansion. It's not violent or chaotic. It's not tearing things apart through brute force. Instead, it's incredibly gentle and precisely organized. Every cubic meter of space expands at exactly the same rate as every other cubic meter. The expansion is perfectly uniform, perfectly smooth, perfectly democratic. Think about what this means for the structure of the universe. As space expands, it doesn't create holes or gaps or empty regions. It doesn't stretch some areas more than others. Every point in space participates equally in the expansion, which means the overall pattern of matter and energy remains remarkably consistent even as the scale changes. This uniformity is what allows us to make predictions about the universe. We can calculate how fast distant galaxies should be receding based on their distance from us. We can predict what the cosmic microwave background should look like. We can model how the large-scale structure of the universe should evolve over time. All of these predictions work because expansion is governed by simple, elegant mathematical relationships. But here's where the story becomes even more fascinating. The expansion we observe today isn't the same as the expansion that occurred in the early universe. The rate of expansion has changed dramatically over cosmic history, telling us a story about the different forces that have dominated the universe at different times. In the earliest moments after the Big Bang, the universe underwent a period called cosmic inflation. During this brief epoch, space expanded exponentially, growing faster than the speed of light. This wasn't objects moving through space faster than light, which is impossible. This was space itself expanding so rapidly that the distance between any 2 points could increase faster than light could travel between them. Inflation solved several puzzles about why the universe looks the way it does today. It explained why the cosmic microwave background is so uniform across the sky. It explained why space appears to be geometrically flat on large scales, and it explained why we don't see certain exotic particles that theories predict should have been created in the Big Bang. But inflation also created something profound. It took quantum fluctuations, tiny random variations in the density of matter and energy, and stretched them to cosmic scales. These fluctuations became the seeds around which galaxies and galaxy clusters would eventually form. Every star you see in the night sky, every planet, every atom in your body can trace its existence back to quantum uncertainties that were inflated to cosmic proportions in the first fraction of a second after the universe began. After inflation ended, the expansion continued, but at a much more sedate pace. For billions of years, the universe was dominated by matter, and gravity gradually slowed the expansion. Galaxies had time to form and evolve. Stars were born and died. Planets formed around some of those stars, and on at least one planet, life emerged and eventually developed the ability to study its own cosmic origins. But then, about 5 billion years ago, something changed. The expansion began to accelerate again. Dark energy, whatever it is, began to dominate the cosmic energy budget. The gentle deceleration that had characterized the universe for most of its history reversed, and space began expanding faster and faster. This transition from deceleration to acceleration represents a fundamental shift in the nature of the cosmos. For most of its history, the universe was fighting against expansion. Gravity was trying to pull everything back together, working against the initial push of the Big Bang. But dark energy changed the rules of the game. Now the universe is actively pushing itself apart, creating more space between galaxies with each passing moment, and this acceleration is accelerating. Dark energy doesn't just provide a constant push, its influence grows stronger as the universe expands, because its density remains constant even as space grows. More space means more dark energy, which means stronger expansion, which creates even more space in an endless positive feedback loop. This creates a strange situation where the universe's future depends on the behavior of something we don't understand. Dark energy could continue at its current strength, leading to eternal expansion. It could weaken over time, allowing gravity to eventually halt and reverse the expansion in a big crunch. Or it could strengthen dramatically, leading to the Big Rip scenario, where expansion becomes so violent that it tears apart the fundamental structure of matter itself. We simply don't know which future awaits us because we don't know what dark energy actually is. It could be a fundamental property of space itself, a quantum field that permeates all of reality, or something even stranger that we haven't imagined yet. What we do know is that it's real, it's measurable, and it's reshaping the cosmos in ways we're only beginning to understand. But let's zoom back out to the bigger picture of what a centerless, expanding universe means for our understanding of existence itself. One of the most profound implications is that it changes how we think about infinity. In a universe with a center, infinity would be something that extends outward from that central point. But in a centerless universe, infinity is everywhere at once. If the universe is indeed infinite in extent, then every point within it is surrounded by infinite space in all directions. There's no edge to approach, no boundary to cross, no ultimate destination to reach. Infinity isn't something far away, it's right here, right now, surrounding you completely. This creates a strange relationship between the finite and the infinite. You exist as a finite being in an infinite space. Your life unfolds over finite time within a potentially eternal cosmos. Your thoughts and experiences are bounded and temporary, yet they occur within a universe that might have no bounds and no end. And if the universe is infinite, then it contains infinite matter and energy arranged in infinite combinations. Somewhere out there, in the endless expanse of space, there might be exact copies of Earth with exact copies of you living exactly the same life. There might be variations where you made different choices, where history unfolded differently, where the laws of physics work slightly differently. This isn't science fiction speculation. It's a logical consequence of infinite space combined with the finite number of ways that matter and energy can be arranged. If you have infinite opportunities for patterns to occur, then every possible pattern, no matter how unlikely, must occur somewhere. And if every possible pattern occurs somewhere, then every possible version of reality exists somewhere in the infinite cosmos. But even if this is true, it doesn't diminish the significance of your particular existence in your particular corner of infinity. You're not just one of infinite copies. You're the unique instance of yourself that exists here and now, experiencing this specific moment in this specific location. The fact that other versions of you might exist elsewhere doesn't make your version any less real or important. Think of it like this. In an infinite library containing every possible book, each individual book is still unique and valuable. The fact that there might be other books with similar stories doesn't make any particular book meaningless. Each book tells its own story in its own way, contributing to the infinite richness of the library as a whole. You are a unique story being told by the universe to itself. Your consciousness, your experiences, your relationships, your thoughts and dreams and fears, all of these represent a completely original narrative that has never been told before and will never be repeated exactly. Even in an infinite cosmos with infinite possibilities, your specific existence is unprecedented and irreplaceable. This brings us to another mind-bending aspect of living in a centerless universe. If there's no absolute reference frame, no cosmic center, no preferred direction, then there's also no absolute meaning or purpose built into the structure of reality itself. The universe doesn't come with an instruction manual or a predetermined plan. It doesn't have goals or intentions or desires. Instead, meaning emerges from within the universe through the actions and choices of conscious beings like ourselves. We don't discover meaning, we create it. We don't find purpose, we choose it. The universe provides the stage and the raw materials, but we write our own scripts and direct our own performances. This is simultaneously terrifying and liberating. Terrifying because it means we're truly on our own, with no cosmic authority to tell us what to do or why we're here. Liberating because it means we have complete freedom to decide for ourselves what matters, what's worth pursuing, what kind of story we want our lives to tell. And here's something beautiful to consider. The same cosmic expansion that reveals the universe has no center also connects us to every other point in space and time. The atoms in your body were forged in the nuclear furnaces of stars that lived and died billions of years ago. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was created by stellar fusion and scattered into space by supernovae. You are literally made of star stuff, as Carl Sagan famously said, but it's more than that. You're made of space stuff. The expansion of the universe created the conditions that allowed those stars to form, to live, to die, and to seed the cosmos with the heavy elements that make complex chemistry and life possible. Every breath you take connects you to the cosmic expansion. The oxygen molecules entering your lungs were created in stars that could only exist because space expanded and cooled enough for matter to condense into stellar nurseries. The expansion that seems to be carrying galaxies away from us is the same expansion that made our existence possible. We are not separate from the cosmos. We are expressions of it. We are the universe becoming conscious of itself, matter and energy organized in such a way that it can contemplate its own existence. Through us, the cosmos experiences wonder, asks questions, seeks understanding. We are the universe's way of knowing itself. And this brings us to perhaps the most profound realization of all. In a centerless universe, consciousness doesn't occupy a special location. It emerges wherever and whenever conditions allow. There's no cosmic headquarters where awareness is concentrated. There's no central command center where the universe thinks its deepest thoughts. Instead, consciousness is distributed throughout the cosmos wherever life evolves to sufficient complexity. Every thinking being on every planet around every star in every galaxy represents a point where the universe becomes aware of itself. We are all equally valid manifestations of cosmic consciousness, all equally legitimate perspectives on the nature of existence. This means that when you look up at the night sky and wonder about your place in the universe, you're not just a tiny speck contemplating something vastly larger than yourself. You're the universe contemplating itself through the lens of your particular consciousness. Your cosmic awareness focused into a specific point of view, experiencing reality from a unique angle that has never existed before and will never exist again. The questions you ask about the cosmos are the cosmos asking questions about itself. The wonder you feel when contemplating infinity is infinity experiencing wonder at its own nature. The search for meaning and purpose that drives human beings is the universe's search for meaning and purpose conducted through conscious agents like ourselves. In this view, science itself becomes a form of cosmic self-reflection. When we study the expansion of space, map the distribution of galaxies, or probe the nature of dark energy, we're not external observers examining something foreign to us. We're the universe using the tools of observation and reason to understand its own structure and evolution. Every discovery we make, every mystery we solve, every new question we formulate represents the cosmos coming to know itself more deeply. The fact that matter and energy can organize themselves into patterns complex enough to study cosmology is perhaps the most remarkable thing about the universe. It suggests that consciousness and curiosity are not accidents, but inevitable consequences of cosmic evolution. This self-reflective aspect of the universe adds another layer to the mystery of cosmic expansion. Not only is space expanding everywhere at once with no center, but it's doing so in a way that eventually produces observers capable of recognizing and understanding that expansion. The universe doesn't just expand, it expands in such a way that it can eventually observe and comprehend its own expansion. Think about the extraordinary chain of events that had to occur for this to be possible. The Big Bang had to happen with exactly the right conditions to allow matter and energy to exist. Cosmic inflation had to stretch quantum fluctuations to just the right size to seed galaxy formation. The fundamental forces had to have exactly the right strengths to allow atoms to form and remain stable. Stars had to be able to form, shine for billions of years, and create heavy elements in their cores. Planets had to be able to form around some of those stars. Chemical evolution had to give rise to biological evolution. Life had to develop increasing complexity over billions of years. And finally, consciousness had to emerge with sufficient sophistication to study cosmology and discover the centerless expansion of space. Every step in this process had to work perfectly for us to be here contemplating the nature of the universe. The cosmic expansion had to proceed at exactly the right rate to allow structure formation without causing immediate collapse or preventing galaxy formation entirely. The physical constants had to fall within narrow ranges that permit the existence of stars, planets, and life. This raises profound questions about whether our existence is an incredible coincidence or whether there's something deeper at work. Some scientists propose that there might be countless universes with different physical laws and expansion rates, and we inevitably find ourselves in one that's compatible with our existence. Others suggest that the universe might be fine-tuned for consciousness in ways we don't yet understand. But regardless of how we got here, the fact remains that we are here. The universe did produce observers. Cosmic expansion did create the conditions for consciousness to emerge, and now that consciousness exists, it can study and appreciate the very expansion that made it possible. This creates a strange loop in cosmic evolution. The universe expands, creating conditions for life and consciousness. Consciousness emerges and studies the universe, discovering its expansion. Through consciousness, the universe comes to understand its own expansion. The process that created consciousness becomes the object of consciousness's investigation. And perhaps most remarkably, this loop of understanding continues to expand along with space itself. As our knowledge grows, as our instruments become more sophisticated, as our theories become more comprehensive, the universe's understanding of itself deepens. We are the cosmos engaged in an ever-expanding project of self-discovery. The centerless expansion of space isn't just a physical phenomenon, it's the backdrop for the universe's journey toward self-awareness. Every galaxy racing away from every other galaxy, every cubic meter of space stretching and growing, every moment of cosmic evolution contributes to the conditions that make consciousness possible. And consciousness in turn contributes to the universe's ongoing story. Through our observations and theories, through our wonder and curiosity, through our very existence as thinking beings, we participate in the cosmos's project of understanding itself. We are not passive observers of cosmic expansion. We are active participants in the universe's quest for self-knowledge. This partnership between cosmic evolution and conscious observation reveals something profound about the nature of existence. The universe is not just a collection of matter and energy evolving according to physical laws. It's a self-organizing system that produces observers capable of studying and appreciating its own organization. In a centerless universe expanding everywhere at once, consciousness emerges not at a single special location, but wherever conditions permit. Every thinking being becomes a point where the cosmos reflects on its own nature. Every question about the universe becomes the universe questioning itself. Every moment of wonder becomes the universe marveling at its own complexity and beauty. And as space continues to expand, carrying galaxies apart and creating new room for existence to unfold, this process of cosmic self-discovery expands along with it. The universe grows not just in size, but in understanding, not just in space, but in awareness, not just in complexity, but in consciousness. We are living through the universe's adolescence, a time when it's beginning to understand itself, to ask deep questions about its own nature, to wonder about its origins and its future. And like any adolescent, the universe is discovering that it's far stranger, far more complex, and far more interesting than it initially imagined. The centerless expansion that once seemed like a simple geometric fact turns out to be the foundation for everything we know about existence. It's the reason stars could form, the reason planets could cool, the reason life could evolve, the reason consciousness could emerge, and the reason we can sit here tonight contemplating the deepest mysteries of reality. In understanding that the universe has no center yet expands everywhere, we've uncovered not just a fact about cosmology, but a truth about consciousness itself. We are the universe's way of experiencing wonder at its own centerless expansion. We are cosmic awareness distributed throughout space and time, each offering a unique perspective on the infinite mystery of existence. And that expansion continues around us and through us and beyond us, creating new space for new possibilities, new opportunities for consciousness to emerge, new chances for the universe to know itself even more deeply. The cosmos that seemed so vast and impersonal reveals itself to be intimate and self-aware, expanding not just in space but in understanding, growing not just in size but in wisdom. Tonight, as you drift off to sleep, remember that you're falling asleep in a universe that's expanding everywhere at once, creating new space between distant galaxies while maintaining the perfect conditions for your existence. You're resting in a cosmos that has no center, yet treats every location with perfect democratic equality. You're part of a universe that's simultaneously infinite and intimate, mysterious and knowable, expanding and conscious. Sweet dreams in your centerless, expanding, self-aware cosmos. Tomorrow, when you wake up, there will be a little more space in the universe than there was tonight. And through your consciousness, there will be a little more awareness of what it means to exist in such an extraordinary reality. And as you wake up to that slightly larger universe, something remarkable happens. Your consciousness emerges from sleep like a spark igniting in the cosmic darkness, and for a brief moment you're experiencing the universe waking up to itself. Every morning, billions of conscious beings across countless worlds open their eyes and begin observing, thinking, questioning. The cosmos stirs to awareness through each of us. But let's talk about what this expanding awareness means for the deepest questions that keep philosophers and physicists awake at night. If the universe truly has no center, if every point in space is equivalent to every other point, then what does that tell us about the nature of existence itself? What does it mean for identity, for uniqueness, for the very concept of location? Here's where things get philosophically twisted. In a centerless universe, the question "where are you?" becomes almost meaningless. You can say you're on Earth, in your solar system, in the Milky Way galaxy, but those are all relative positions. Earth is somewhere relative to the Sun. The solar system is somewhere relative to the galactic center. Our galaxy is somewhere relative to other galaxies. But none of these positions are absolute. There's no cosmic GPS system with a universal origin point. You exist at coordinates that only make sense in relation to other objects, which themselves only make sense in relation to still other objects, in an endless chain of relative positions that never anchors to any absolute reference point. It's like trying to give directions in a world where every landmark is constantly moving and there are no fixed streets or addresses. This relativity of position extends to time as well. When did the universe begin? 13.8 billion years ago, we say. But ago relative to what? Relative to now, wherever and whenever now happens to be. An observer in a different galaxy, living in what we call the past or future, would measure the age of the universe relative to their own now. Time, like space, has no absolute reference frame. This creates a strange situation where every moment in time has an equal claim to being the present. The Big Bang isn't something that happened in the past. It's something that happened 13.8 billion years before whatever moment you choose to call now. Change your definition of now, and you change when the Big Bang occurred relative to that moment. But here's where the cosmic expansion adds another layer of strangeness. Because space is expanding, the distance between any two events depends on when you measure it. The distance between our galaxy and a distant quasar isn't a fixed number. It's constantly changing as space stretches between them. If you measured it yesterday, you'd get one answer. If you measure it tomorrow, you'd get a different answer. This means that even the most basic measurements we make about the universe are time-dependent. The size of the observable universe, the distance to the cosmic microwave background, the recession velocity of distant galaxies, all of these are constantly changing because expansion never stops. It's like trying to measure a balloon while someone is inflating it. Every measurement you make is instantly obsolete because the balloon has grown since you finished measuring. The universe is that balloon, and we're trying to understand its properties while it continuously changes around us. This dynamic nature of cosmic measurements reveals something profound about the relationship between observation and reality. We often think of the universe as a static stage where events play out. But the stage itself is evolving, growing, changing its fundamental properties even as we try to study them. When ancient astronomers looked up at the night sky, they saw what they called the fixed stars, points of light that maintained the same relative positions night after night, year after year, century after century. The heavens seemed eternal and unchanging, a perfect contrast to the chaotic, temporary world below. But we now know that nothing in the universe is truly fixed. Every star is moving through space. Every galaxy is rotating and evolving. Every point in space is participating in cosmic expansion. The apparent stability that ancient observers saw was just an illusion created by the vast scales of space and time involved. Even the cosmic microwave background, that ancient afterglow of the Big Bang that seems so permanent and unchanging, is actually evolving. Its temperature drops as the universe expands. Its wavelengths stretch as space grows. Billions of years from now, it will be so redshifted and diluted that future astronomers might not be able to detect it at all. This evolutionary aspect of the cosmos means that the universe we observe today is fundamentally different from the universe that existed billions of years ago, and it will be fundamentally different from the universe that will exist billions of years in the future. We're not just observing a static arrangement of matter and energy. We're witnessing a single frame in an ongoing cosmic movie. And here's something that will really bend your mind. Because we can only observe light that has had time to reach us since the Big Bang, we're always looking at an outdated version of the universe. That distant galaxy you see in a telescope image might have evolved dramatically, moved to a different location, or even been destroyed by now. But we won't know about it until the light carrying that information has time to cross the vast distances involved. This creates a strange situation where our knowledge of the universe is always incomplete and always changing. We're constantly receiving updates about events that happened millions or billions of years ago. It's like reading a newspaper that's always years out of date, where the headlines describe events from the distant past and the real current events remain unknown. The expansion of space makes this information delay even more complex. Light from distant objects doesn't just take time to reach us. It gets stretched and redshifted during its journey, carrying information about both the object that emitted it and the expansion of space that occurred while the light was traveling. Every photon that hits your eye or a telescope detector is like a messenger that's been traveling for millions or billions of years, carrying news from ancient times while being modified by the expansion of space itself. The universe sends us constant updates about its past, but those updates are written in a code that we have to decipher to understand what really happened. And as space continues to expand, this communication system between different parts of the universe becomes increasingly strained. Objects that we can see today will eventually be carried so far away that their light will never reach us again. The observable universe will gradually shrink as galaxies disappear beyond our cosmic horizon. Future astronomers living billions of years from now might see a nearly empty universe with just a few nearby galaxies visible in their sky. They might conclude that the universe is small, static, and sparsely populated, never guessing that they're living in the expanded remnant of a cosmos that was once filled with hundreds of billions of galaxies. This raises a humbling question. What are we missing about the universe today because expansion has already carried crucial evidence beyond our ability to observe it? What galaxies, what phenomena, what cosmic events have already been stretched so far away that we can't see them? How much of the universe's story remains forever hidden from us? The centerless expansion that reveals so much about the cosmos also conceals vast amounts of information. It's like being handed a book where most of the pages have been torn out, and the remaining pages are constantly fading as you try to read them. We're working with incomplete information about an evolving system, trying to understand the whole from fragments of the past. But perhaps that's exactly what makes the universe so fascinating. If we could see everything at once, if all information were instantly available, if the cosmos revealed all its secrets immediately, would it be as compelling? Would we be as driven to understand it? Would the search for knowledge carry the same excitement and mystery? The centerless expansion creates a universe of hidden wonders, of mysteries that reveal themselves slowly, of discoveries that await future generations of observers. It ensures that the cosmic story remains perpetually unfinished, always offering new chapters for consciousness to explore. Every generation of astronomers sees a slightly different universe than the generation before them, not just because our instruments improve or our theories evolve, but because the universe itself is changing, expanding, revealing new aspects of its structure while concealing others beyond the reach of observation. We live in a unique moment in cosmic history. We can still see the cosmic microwave background, the afterglow of the Big Bang. We can observe galaxies that formed when the universe was young. we can detect the acceleration of expansion and the effects of dark energy. Future observers might not have access to this same evidence. In a sense, we're living in the universe's golden age of self-discovery. The cosmos is old enough to have developed complex structure and conscious observers, but young enough that the evidence of its origins remains visible. We exist in a brief window of cosmic time when the universe can study its own beginning. This temporal perspective adds urgency to our cosmic investigations. We're not just trying to satisfy human curiosity about the nature of existence. We're participating in a time-limited opportunity for the universe to understand itself. The evidence we can gather today might not be available to future generations of cosmic investigators. And this brings us back to the profound connection between cosmic expansion and consciousness. The same process that creates new space between galaxies also creates new opportunities for awareness to emerge. As the universe expands and cools, new regions become hospitable to complex chemistry, to planetary formation, to biological evolution, to the emergence of consciousness. But expansion also creates a deadline. Eventually, if current trends continue, the universe will expand so much that new star formation will cease, existing stars will burn out, planets will freeze as their suns die. The cosmic environment will become increasingly hostile to complex structures and conscious observers. We exist during a brief era when the universe is capable of producing and sustaining consciousness, and when that consciousness can still observe and understand cosmic expansion. We're living in the universe's window of self-awareness, a temporary epoch when matter and energy have organized themselves into patterns complex enough to study their own cosmic origins. This creates a beautiful symmetry. The expansion that began with the Big Bang will eventually make life impossible, but in between those two extremes, it creates exactly the conditions needed for consciousness to emerge and understand the expansion itself. The universe becomes aware of its own growth just as that growth begins to threaten the very possibility of awareness. It's like a flower that blooms just long enough to appreciate its own beauty before the season changes and it fades away. The cosmos develops consciousness just in time to marvel at its own expansion before that expansion carries everything too far apart for life to continue. But even if consciousness is temporary on cosmic scales, even if the universe's self-awareness lasts only a brief moment in cosmic time, that moment is still real and meaningful. Through us, through every conscious being that has ever existed or ever will exist, the universe experiences wonder, asks questions, seeks understanding. We are the cosmos thinking about itself during its brief phase of self-reflection. We are matter and energy arranged in patterns complex enough to contemplate the expansion of space. We are the universe's way of experiencing surprise at its own centerless democratic structure. And perhaps that's enough. Perhaps the fact that the universe can produce observers capable of understanding cosmic expansion, even temporarily, is itself a kind of triumph. Perhaps consciousness doesn't need to last forever to be meaningful. Perhaps the universe's brief moment of self-awareness is worth all the billions of years of unconscious expansion that preceded it and may follow it. In a centerless universe expanding everywhere at once, consciousness emerges not as a permanent feature, but as a temporary flowering of complexity and awareness. We are cosmic blossoms in the garden of space-time, blooming for a moment before the expansion carries us beyond the conditions that make our existence possible. But what a moment it is! What an extraordinary opportunity to witness, to understand, to appreciate the vast cosmic dance of which we are part. What a privilege to be the universe's eyes and mind during its adolescent phase of self-discovery. As space continues to stretch between distant galaxies, as dark energy continues to accelerate the expansion, as the cosmos grows larger and colder and emptier, consciousness continues its investigation. Every observation we make, every theory we develop, every moment of wonder we experience adds to the universe's understanding of itself. We are temporary patterns of matter and energy that have learned to contemplate the permanent expansion of space. We are finite beings studying infinity. We are conscious observers in a centerless cosmos, each offering a unique perspective on the infinite mystery of existence. And tomorrow, when you wake up in a universe that's grown a little larger overnight, remember that you're participating in the most extraordinary story ever told. The story of a cosmos that has no center yet expands everywhere, that produces consciousness capable of understanding its own expansion, that creates observers who can marvel at the very process that made their existence possible. You are living proof that the universe is stranger, more beautiful, and more self-aware than anyone ever imagined. You are the cosmos contemplating itself in the brief window of time when such contemplation is possible. You are the universe's way of experiencing wonder at its own centerless, expanding, mysterious nature. Sweet dreams in your growing cosmos, where every point is equally valid, every observer equally important, and every moment of consciousness equally precious in the vast democratic expanse of space and time. And that brings us to perhaps the most beautiful paradox of all. In a universe that has no center, you are simultaneously utterly insignificant and absolutely central to everything that matters. You're one tiny arrangement of atoms in an infinite cosmos, yet you're also the unique point of awareness through which the universe experiences this particular moment, this particular perspective, this particular flash of consciousness. Every thought you have about cosmic expansion is the universe thinking about its own growth. Every moment of awe you feel when contemplating the vastness of space is the cosmos experiencing wonder at its own scale. Every question you ask about the nature of existence is existence questioning itself through the lens of your consciousness. This isn't metaphorical poetry. This is literal truth. You are made of matter that was forged in stellar cores, organized by the same physical laws that govern galactic motion, powered by the same energy that drives cosmic expansion. There's no meaningful boundary between you and the universe you're observing. You are the universe, temporarily organized into a pattern capable of self-reflection. And here's what makes this even more extraordinary. The expansion that seems to be carrying everything away from everything else is actually what makes connection possible. Without cosmic expansion, without the cooling and stretching of space over billions of years, matter would never have had the opportunity to organize itself into the complex structures that make consciousness possible. The same process that creates distance between galaxies creates the conditions for intimacy between conscious beings. The expansion that seems to isolate us in a vast, cold cosmos is actually the expansion that allows warm planets to exist, complex chemistry to unfold, life to emerge, and minds to connect across the apparent emptiness. When you look into someone's eyes and feel that spark of recognition, that sense of connection that transcends the physical space between you, you're experiencing the universe connecting with itself across the expansion of space. Two arrangements of cosmic matter, separated by the growth of space-time, yet united by the shared experience of consciousness. This is the ultimate magic trick of a centerless, expanding universe. It creates the illusion of separation while maintaining the reality of connection. Every atom in your body was once inside a star. Every breath you take connects you to the atmosphere that connects you to the biosphere that connects you to the planet, that connects you to the solar system, that connects you to the galaxy, that connects you to the cosmic web of structure that spans the observable universe. You are not isolated in the expanding cosmos. You are woven into its very fabric, a conscious thread in the vast tapestry of space-time. The expansion doesn't separate you from the universe. It is the universe, and you are part of it, experiencing its own growth from the inside. And as we reach the end of our journey tonight, as your mind struggles to hold on to these impossible concepts, remember that the struggle itself is beautiful. The fact that a collection of atoms organized into the pattern you call yourself can even attempt to understand cosmic expansion is perhaps the most remarkable fact in all of existence. You don't need to fully grasp how the universe can expand everywhere at once with no center. You don't need to completely understand how space can stretch without stretching into anything. The mystery isn't a failure of explanation. The mystery is the point. The universe is under no obligation to make sense to human intuition. What matters is that you've taken this journey. You've allowed your mind to stretch along with space itself, to expand beyond the comfortable boundaries of everyday experience, to grapple with concepts that challenge everything your brain thinks it knows about reality. You've experienced what it feels like to be a conscious being in a centerless cosmos, a temporary pattern of complexity in an expanding universe, a fleeting moment of self-awareness in the infinite dance of matter and energy and space-time. Tonight, when you close your eyes and try to sleep, your brain will attempt to process these ideas, to integrate them with everything else you know about existence. Some of it will stick, some of it will fade, but something will remain. A sense of wonder, perhaps, a feeling of connection to something vast and mysterious, an awareness that you are part of a story much larger and stranger than you ever imagined. And tomorrow, when you wake up in a universe that has grown measurably larger during your sleep, when you step outside and look up at a sky full of galaxies racing away from you at incredible speeds, you'll know something that most humans throughout history could never have known. You'll know that you live in a cosmos with no center and no edge, expanding everywhere at once, creating new space between distant objects while maintaining the perfect conditions for your existence. You'll know that every point in this universe has an equal claim to importance, including the point where you happen to be standing. You'll know that the expansion you can't feel is the expansion that made your life possible. You'll know that the cosmos that seems so vast and impersonal is actually intimate and self-aware, experiencing itself through your consciousness. You'll know that in a universe where everything is moving away from everything else, the most profound connections remain unbroken. The connection between matter and energy, the connection between space and time, the connection between cosmic evolution and conscious awareness, the connection between the expansion of the universe and the expansion of understanding. And you'll know that you are not just observing this cosmic dance from the outside. You are part of the dance itself. You are the universe celebrating its own expansion, marveling at its own structure, questioning its own nature. In a centerless cosmos expanding everywhere at once, you are both infinitely small and infinitely significant. You are the point where the universe becomes aware of its own mystery. You are the moment when matter looks at itself and wonders how it got here. You are consciousness flowering in the garden of space-time. The universe has no center, but you are the center of your own experience of it. Space expands everywhere, but your awareness makes one small piece of that expansion meaningful. The cosmos is vast beyond comprehension, but it has organized itself in such a way that you can comprehend at least a fragment of its vastness. And that perhaps is the most beautiful truth of all. In a universe that could have remained forever unconscious, forever unaware of its own expansion, matter has arranged itself into patterns capable of wonder. Space has stretched and cooled and evolved in such a way that consciousness can emerge to study the stretching itself. You are the universe's gift to itself, a moment of self-awareness in the expanding darkness, a point of light in the cosmic night, capable of understanding that the night itself is growing larger, more mysterious, more wonderful with each passing moment. Sweet dreams in your centerless, expanding, self-aware cosmos. May your consciousness rest peacefully in the knowledge that you are exactly where you belong, in a universe that treats every location with perfect democratic indifference and every moment of awareness with infinite preciousness. And when you wake up tomorrow morning, something remarkable will have happened while you slept. The universe will have grown, not by much in human terms, but measurably, detectably, undeniably. Every cubic meter of space will have stretched just a tiny bit more. Every distant galaxy will have moved just a little farther away. The cosmic microwave background will have cooled by an infinitesimal amount as its wavelengths stretched with the expansion of space itself. You won't feel any different. Your body won't have expanded, your house will be the same size, the Earth will still orbit the Sun at the same distance. But the space between galaxy clusters will have grown. The observable universe will have a slightly larger radius. The most distant objects we can see will be a little bit farther away than they were when you went to sleep. This is happening right now. As you listen to these words, space is expanding around you, through you, between every atom in your body and every star in the sky. The expansion is so gentle, so uniform, so perfectly democratic that it affects everything equally, which means you can't feel it happening. But it's there, constant and relentless, the heartbeat of the cosmos itself. And here's what's truly extraordinary about this moment in cosmic history. You exist during the brief window of time when the universe is old enough to have developed consciousness, yet young enough that conscious beings can still observe the evidence of cosmic expansion. You live in an era when the cosmos can study itself, when matter has organized into patterns complex enough to understand the very expansion that made those patterns possible. Billions of years from now, if consciousness still exists somewhere in the universe, those future observers might look out at a nearly empty sky. The expansion will have carried most galaxies so far away that their light can no longer reach any observer. The cosmic microwave background might be so red-shifted and diluted that it becomes undetectable. The evidence for the Big Bang, for cosmic expansion, for the universe's dramatic history might be gone forever. But you're here now in this golden age of cosmic self-discovery. You can see galaxies that formed when the universe was young. You can detect the afterglow of creation itself. You can measure the acceleration of expansion and wonder about the nature of dark energy. You are participating in the universe's brief moment of self-awareness, its adolescent phase of asking deep questions about its own nature. This makes every observation precious, every measurement irreplaceable, every moment of wonder significant. You're not just satisfying human curiosity about the cosmos. You're helping the universe understand itself during the limited time when such understanding is possible. You're part of a cosmic project of self-discovery that may never be repeated once expansion carries the evidence beyond the reach of any possible observer. And that brings us to something that might seem contradictory but is actually profound. In a universe with no center, no special locations, no preferred reference frames, the act of observation creates temporary centers of meaning. Not physical centers, but centers of awareness, points where the cosmos becomes conscious of itself. Every time you look up at the night sky and feel that sense of awe, you're creating a moment where the universe experiences wonder at its own vastness. Every time you think about cosmic expansion, you're generating a temporary focal point where the cosmos contemplates its own growth. Every question you ask about the nature of existence becomes a center of inquiry where the universe investigates itself. These centers of meaning don't violate the centerless nature of physical space. They emerge from it. In a cosmos where every location is equivalent, consciousness can arise anywhere, creating countless points where the universe becomes aware of its own structure. Each conscious being becomes a temporary center of cosmic self-reflection, equally valid, equally important, equally meaningful. You are one of these centers right now. As you process these ideas about expansion and infinity and centerlessness, you're serving as a focal point where the universe thinks about itself. Your confusion, your wonder, your struggle to understand concepts that challenge human intuition, all of this is the cosmos grappling with its own nature through the lens of your consciousness. The questions that arise in your mind are the universe questioning itself. The moments of clarity when a concept suddenly makes sense are moments when the cosmos achieves understanding of its own structure. The sense of vertigo you might feel when contemplating infinity is the universe experiencing amazement at its own scale. And here's something beautiful to consider as we draw near the end of our journey tonight. The centerless expansion that seems to isolate every point in space actually creates infinite opportunities for connection. In an infinite or nearly infinite universe, every possible pattern of matter and energy will eventually occur somewhere. Every possible arrangement of atoms, every possible configuration of thoughts and experiences, every possible moment of consciousness. This means that the thoughts you're thinking right now, the specific pattern of neural activity that constitutes your understanding of cosmic expansion, represents a unique moment in the universe's ongoing project of self-discovery. Your particular perspective, your individual consciousness, your specific way of processing these ideas has never existed before and will never exist again in exactly the same way. Even if there are other versions of you in distant parts of an infinite cosmos, even if similar thoughts arise in other minds around other stars, your specific instance of consciousness happening here and now is unprecedented and irreplaceable. You're a completely original contribution to the universe's understanding of itself, and that understanding continues to expand along with space itself. Every generation of conscious beings adds new layers to cosmic self-awareness. Every discovery about the nature of expansion deepens the universe's knowledge of its own structure. Every moment of wonder contributes to the cosmos's ongoing appreciation of its own mystery and beauty. We stand at a remarkable point in this process. Human consciousness has evolved to the point where we can detect and measure cosmic expansion, map the large-scale structure of the universe, and begin to understand the fundamental forces that shape reality. We've become sophisticated enough to realize that the cosmos has no center, yet democratic enough to recognize that this makes every perspective equally valid. Our instruments can detect the cosmic microwave background, measure the recession velocities of distant galaxies, and observe the acceleration of expansion driven by dark energy. Our theories can predict how the universe will evolve over billions of years, from its hot, dense beginning to its cold, sparse future. Our mathematics can describe the geometry of expanding space-time, even when our intuition fails to grasp it. But perhaps most remarkably, our consciousness can appreciate the profound implications of living in a centerless, expanding cosmos. We can feel wonder at the democratic nature of space, where every location has an equal claim to importance. We can experience awe at the realization that we're part of an infinite or nearly infinite universe that's constantly creating new space for existence to unfold. We can understand, at least intellectually, that the expansion carrying distant galaxies away from us is the same expansion that made our existence possible. We can grasp the beautiful paradox that in a universe with no center, consciousness can emerge anywhere to serve as a temporary focal point for cosmic self-reflection. And we can recognize that this moment of understanding is itself part of the cosmic story. The universe's brief phase of self-awareness, its temporary ability to study its own expansion through conscious observers like ourselves, represents a remarkable chapter in the ongoing evolution of matter and energy and space-time. As space continues to expand, as dark energy continues to accelerate the cosmic growth, as galaxies race away from each other at ever-increasing speeds, consciousness continues its investigation. Every night, observers around the world point telescopes at the sky and gather new data about cosmic expansion. Every day, theorists work to refine our understanding of how space-time behaves on the largest scales. This ongoing project of cosmic self-discovery is distributed across countless minds, countless perspectives, countless moments of insight and wonder. No single consciousness could comprehend the full scope of the expanding universe, but collectively, through the combined efforts of all conscious beings, the cosmos gradually deepens its understanding of itself. You are part of this collective investigation. Every time you think about the implications of a centerless universe, every moment you spend contemplating the meaning of cosmic expansion, every question you ask about the nature of existence, you're contributing to the universe's ongoing project of self-awareness. Your individual consciousness may be temporary, a brief flowering of complexity in the expanding cosmos. But your contribution to cosmic understanding becomes part of a larger pattern that transcends any individual mind. Through the shared project of scientific inquiry, through the accumulated wisdom of countless observers, through the ongoing conversation between minds trying to understand their place in an infinite cosmos, consciousness creates something greater than the sum of its parts. The universe becomes aware of itself not through any single perspective, but through the collective efforts of all conscious beings working together to understand the nature of existence. Your thoughts about cosmic expansion become part of a vast, distributed investigation that spans space and time, connecting minds across vast distances in a shared quest for understanding. And that investigation continues to expand along with the universe itself. As space grows larger, as new regions become hospitable to complex structures, as consciousness potentially emerges in new locations throughout the cosmos, the universe's capacity for self-understanding grows as well. We are living through the early stages of this process. The universe is young, consciousness is rare, and most of space remains unexplored, but the potential for awareness, for understanding, for appreciation of cosmic beauty exists everywhere that matter and energy can organize themselves into sufficiently complex patterns. In the billions of years ahead, if consciousness persists and spreads throughout the cosmos, the universe's understanding of itself could grow beyond anything we can currently imagine. Minds far more sophisticated than ours might develop theories we can't conceive, make observations we can't perform, achieve insights we can't fathom. But even those future developments will build on the foundation being laid right now, in this moment, through your consciousness and countless others like it. The wonder you feel when contemplating a centerless, expanding universe contributes to a growing wave of cosmic self-awareness that may eventually span the entire cosmos. You are part of the universe's awakening to its own nature. Your consciousness represents a point where matter has become complex enough to study the very expansion that made that complexity possible. Your thoughts about infinite space and centerless geometry are the cosmos thinking about its own structure. And as you prepare to rest tonight, as your mind gradually releases its grip on these impossible concepts, remember that the expansion continues around you and through you and beyond you. Space grows larger while you sleep. Distant galaxies race away at incredible speeds while you dream. The cosmic microwave background cools and stretches while your consciousness rests. But the investigation never stops. Somewhere in the expanding universe, conscious beings are making new observations, developing new theories, experiencing new moments of wonder. The cosmos continues its project of self-discovery, even when individual minds need to rest. Tomorrow, when you wake up in a universe that has grown measurably larger overnight, you'll have another opportunity to participate in this ongoing investigation. You'll be able to look up at a sky full of galaxies and know that you're seeing a cosmos with no center yet expanding everywhere, creating new space between distant objects while maintaining the perfect conditions for your existence. You'll know that you're not just observing this cosmic dance from the outside, but participating in it from within. You are the universe experiencing wonder at its own expansion. You are consciousness flowering in the garden of space-time. You are the cosmos celebrating its own democratic, centerless, endlessly creative nature. In a universe that expands everywhere at once with no center, you are both infinitely small and infinitely significant. You are a temporary pattern of matter and energy that has learned to contemplate the permanent expansion of space. You are a finite consciousness studying infinity itself, and that may be the most beautiful truth of all. In a cosmos that could have remained forever unconscious of its own expansion, matter has organized itself into patterns capable of understanding that expansion. Space has evolved in such a way that consciousness can emerge to study the evolution of space itself. You are proof that the universe is not just vast and mysterious, but also self-aware and endlessly creative. You are evidence that cosmic expansion leads not just to larger distances between galaxies, but to greater opportunities for consciousness, understanding, and appreciation of the infinite mystery of existence. Sweet dreams in your centerless, expanding, self-aware cosmos, where every point in space has an equal claim to importance. Every moment of consciousness contributes to cosmic understanding, and every dream you dream is the universe dreaming about itself in the endless democratic expanse of space and time.